Welcome back. So when an earthquake occurs, and seismic waves and this release of energy are rippling through the crust, through the mantle and parts of the core, depending on the type of wave. So when these seismic waves hit a location, what sort of hazards are created? Obviously, the ground shaking, but is that it? And is that ground shaking responsible for most of the death and destruction that occurs? It might sound like a weird question to ask, but let's dive into this. So what are the associated hazards to an earthquake? Well, there is the primary hazard. It's the ground quaking itself, all right? So any damage directly related to the ground shaking is related to that primary hazard of the ground quaking. Collapsing buildings, bridges, roadways, these things occur because the ground is shaking, causing them to crumble. Okay. So the quaking is a primary hazard. However, there are also things called secondary hazards. Secondary hazards is when the quaking causes some other type of destructive force. All right? So let's say an earthquake occurs, your house is fine. But the earthquake for some reason triggered a landslide, and the landslide came and buried your house. That would be a secondary hazard. Or your house survived the shaking, the quaking, but for some reason, the earthquake ruptured gas lines, the house next to you caught on fire, your house now catches on fire. It's a secondary hazard. Tsunami. So, for instance, the ground shakes, nothing happens, but in some cases, if earthquakes occur underneath the ocean, depending on the type of earthquake and the severity of the earthquake, it can cause a tsunami, a giant mega wave that races in. And maybe your house survives that, but the tsunami comes in and destroys your house. As well as something called ground liquefaction. This is kind of an interesting one. It's when an earthquake occurs, it's not the shaking that damages your house or your car or vehicle or whatever. But in some cases, a lot of times, when you live in a place near the shore, near the ocean, or near an area that has a lot of water around it, if the ground itself is saturated with water, when the shaking occurs, that could take that ground, and it doesn't have to be like a bunch of water, but just saturated with water. It can take that ground and turn it into almost liquid, like quicksand almost. And so when the shaking occurs, that didn't damage your house, but the shaking caused the ground to liquefy, and the liquefied earth sucks your house in. Or in this case, with this image, this isn't just part of a car just cut and set on the ground as some sort of art installation. That car was swallowed. All right, you can see this area maybe a little bit more sandy. I see palm trees, so I'm guessing maybe someplace tropical near a beach, so close to water. So the ground is probably pretty saturated with water. So when an earthquake occurred in this location, the ground turned to almost quicksand and just sucked that car right in. And the thing with secondary hazards, they can cause more damage, destruction, death than the original quake itself. A lot of times when negative things happen geologically, it's not the primary hazard, oftentimes the secondary hazard. And we deal with this a lot in one of my different classes, GLG101IN. But in this case, with earthquakes, again, that secondary hazard can cause almost more damage than the original quake itself. All right. So here's a couple of videos I want you to watch that deal with ground liquefaction. The first is a construction site where they kind of jiggle the ground, and you'll be able to see it almost. It kind of moves like Jello. It's kind of scary that it looks like they're about to build something on this ground that is undergoing liquefaction. But hey, we build weird places. And in the second video, this is during one of the larger earthquakes that happened in Japan, I believe in 2011. This person was walking through a park, and this park is on reclaimed land, so it was once the ocean, but they kind of filled it in with dirt and rocks to create a park, to create new land, so it is heavily waterlogged. And so this person is walking through the park during an earthquake, and you'll see liquefaction taking place. Liquefied earth just kind of spewing out of the ground, giant cracks in the earth opening up. It's pretty scary to watch. So make sure you're watching these videos. They are linked below, but they're also obviously in the PowerPoint. So now we'll pause here. When we come back, we'll talk about how earthquakes and seismic waves specifically have helped us infer what's inside the Earth's interior. I'll see you back here in just a second.